Gravimetric corrosion tests and surface analysis of SUS310S in model Seawater. What is gravimetric analysis? It is an analytical technique used to quantify the amount of an analyte based on the mass of a solid. There are different types of gravimetric analysis such as volatilization gravimetry, precipitation gravimetry, electrogravimetry, and thermogravimetric.
Corrosion test is carried out to evaluate the durability of materials of construction in reactive environments. It is also to evaluate a range of material degradation processes that affect the final performance of these materials and directly influence the materials chosen for these applications.
A surface characterization is used to quantify surface under investigation. XPS is used in this experiment to measure the elemental composition presence by emitting electrons with kinetic energy to the solid samples. Methodology. First, the specimen will be embedded in epoxy resin and the exposed surface were abraded by silicon carbide paper. The contamination will be removed by ultrasonic cleaning. Next, 4 test solution were prepared by adjusting the Cl concentration similar to the concentration of seawater including NaCl, MgCl2, ZnCl2 and AlCl3. The solutions were all transparent and neutral. To undergo gravimetric test, the specimen were immersed in solution 12 weeks at 25 degrees Celsius and cleaned ultrasonically after immersion. The corrosion rate can be calculated based on the mass loss of the sample using the equation. For surface characterization, the specimen's surfaces were observed by scanning electron microscope. Specimen's surface was cleaned ultrasonically after the immersion and analyzed by X-ray photoelectron spectroscope using an alpha X-ray source. Based on the gravimetric test results, no change of the appearance of the solutions were observed after 12 weeks of corrosion tests. Steel in Zn solution has lowest weight loss which shows the lowest corrosion rate. Also, the pH values increased slightly after the test due to the formation of hydroxide ion. For surface characterizations, small pits observed in the 4 samples where the pits are different in each other. White pits were observed in the sample that immersed in Zn solution. For the XPS result, it shows that Zn2+ and Al3+ presented on the surface after the immersion for sample immersed in Zn solution and Al solution while Na+ and Mg2+ do not presented in Na solution and Mg solution.
The overall corrosion scenario in this study is the hard metal cation incorporate in the oxide film and attract the electron pair of oxygen atom in H2O or O in the film, form a metal cation layer on the oxide film. The layer of metal cation protects the oxide film from Cl attack and inhibits the corrosion reactions of steel. The layer of metal cation act as a barrier for the chloride ions as well as for the corrosion reactions.
That's all for our presentation. Thank you.